Hello, everyone. This is Mrs. Salter, and today we're going over assignment C3-S1 gravity probe. What are some places where gravity exists? They know the reason things on Earth fall to the ground is because of gravity. Put an X next to all the places where you think gravity exists. As we learned in class, anything with mass has gravity. So the Earth's moon has mass. Saturn has mass. Has mass. Even the air on Earth has mass. When you blow up a balloon, your air fills the balloon because your air has mass. And even though it has very low amount of gravity, the air on Earth does have mass and therefore have gravity. The sun has gravity. Stars have gravity. The Milky Way galaxy has gravity because it has mass. Neptune has mass. Even very, very far away places in the universe that have mass have gravity. And the outside of Earth's atmosphere has mass and therefore has gravity. Gravity, the property of all objects with Part 2. Imagine that a hole was dug from where you live to the opposite side of the Earth. Now imagine that you accidentally fell into the hole. Whoops. Choose the scenario that you think best describes what would happen to you and explain why you chose that scenario. Scenario A, you would fall all the way through the hole and out into space. Scenario B, you would fall all the way through the hole and land on the other side of the Earth. Scenario C, you would stop falling as soon as you reach the center of the Earth. Scenario D, you would fall to the opposite side of the Earth and then you would fall back towards where you live. And this back and forth pattern would continue until you eventually stopped at the center of the Earth. I choose scenario D. Scenario D is correct. The person would be falling so they would bypass the center of the Earth at first, but the Earth's gravitational pull would eventually pull the person towards the center. Weight and jump distance on other planets. Create a hypothesis concerning the relationship between mass and gravitational force. So if an object has, we're going to say, more mass, then it will have a stronger gravitational force. So the next thing we're going to do is calculate your weight on the moon and planets in our solar system using the following equation. So you're going to take your weight on Earth times the gravity, which is listed here in column B, and that is going to be your weight on another planet. So if you don't want to put in your weight, you can use the weight of the astronaut from our special question, which is 150 pounds. So you're going to get your calculator. So you can use either a Desmos calculator or you go, if you have a Chromebook and you go to where the little circle is and choose your apps, you have a calculator app. So I'm going to pull up my calculator app. And I'm going to, whoops, let's see, I think that I have to do it this way. So I'm going to pull up my calculator app and I'm going to calculate my weight on Earth times the gravity of a particular celestial body. So I'm going to take 150 times 0.17, and that's what I would weigh on the moon. That would be 25 point, come on, click. Oh, that's right. 25.5 pounds. Okay. And then I'm going to take my weight times the gravity on Mercury. And that would be 57 pounds. And so your weight may be different than the weight that I'm using. So whatever your weight is, unless you don't want to share your weight, but whatever your weight is times the gravity will be your answer. If you don't want to share your weight, you can just use 150 from our discussion question. And you'll need to complete the table. So I'm only going to give you the answers for the first 4 planets and the moon. And you're going to have to calculate the other 4 planets on your own. These first 4 planets are the inner planets, and they're going to be the planets that we're going to graph. On your own, you'll need to calculate your weight times the gravity of the particular planet and type your answer here in this column, and make sure that you label your weight as pounds. What patterns do you observe in the data table above? A planet with a larger mass has a stronger gravitational force. On planets with a stronger gravitational force, your weight is calculated as what? So of the inner planets, Earth has the strongest gravity. And so there my weight is more than if it is on the moon, which is the weakest of these celestial bodies. The weakest gravity of these celestial bodies. So with a stronger gravitational force, then my weight is calculated. The next thing that we're going to do is graph our data. So you will create a scatter plot. Your graph will depict the mass of a planet versus your weight on that planet, where the mass of the planets are labeled on the x-axis and your weight is labeled on the y-axis. Only graph the inner planets and the moon. Label your plots and planet names. Complete in the Nearpod. Now your Nearpod code may be different depending on what class you're in. Each class has its own Nearpod code. So you should use the code that's on your worksheet, or you can just click the link and it'll take you directly to Nearpod. I'm going to graph my inner planets. And just to make it easier for myself, I'm going to highlight just the section that I need to be looking at. Please be sure to type in your first and last name whenever you join a Nearpod. There are some students that haven't always gotten credit for their work because they don't type their first and last name, or they just type their nickname. So I've already read the directions that we are going to create a scatter plot depicting our weight on the different planets, our heavenly bodies. I'm going to put the instructions away. So the first thing that I'm going to graph is my weight on the moon. So I'm going to look at the mass of the planet, and the mass of the planet is down here. It's my x-axis, and then my weight is my y-axis. So the mass of the moon compared to Earth is 0.0123. So that means that I'm going to put my point very close to the 0, and 25.5 pounds. I'm going to draw my dot very close to the 0. 25.5 pounds is going to be sort of in between the 20 and the 30. So I'm going to put my dot right here. And then I'm going to label my dot. I'm going to make sure that my text is the same color as my dot so that it's easy to match the text to the dot. Move my text right here next to my dot. Next is Mercury, 0.055 and 57 pounds. So that means that my 0.055, I'm gonna make Mercury red. Each planet should be a new color. 0.055 is going to be in between these first two lines. And my weight on Mercury was 57 pounds. That's just under the 60. So I'm gonna put my dot right. Label it Mercury. Next is Venus at 0.815. And point Venus, I think I will make Venus green, 0.8, and about 100. Mars. Orange. Here. So now that I've graphed all the inner planets, I need to be sure that I hit submit on my Nearpod, and it will take me to our next graph. We're going to get to that. So for the next part of our experiment, you're going to have to calculate your standing long jump or your broad jump. So you're going to put a piece of tape on the floor. You're going to jump as far as you can, and then you're going to put another piece of tape or a pencil or something to indicate where you landed, and you're going to measure this distance. Be sure that you put your record your distance in centimeters. We have a little video on how to do that. You need a stick, a tape measure, tape. You don't have to have cones. You can buy one of these tape measures at the Dollar Tree. I apologize, I had a little bit of technical difficulty there, but you're going to put a piece of tape down on the floor and you're going to jump as far as you can, put another piece of tape down to mark where the end of your jump, and then you're going to measure how far you jumped in centimeters. And And then you're going to record that distance here on your assignment. You're going to jump 5 times. So whatever you jump, you're going to record that in centimeters in your table. Now you should, if you jump 5 times, you should get 5 different jump distances. However, I'm going to use 100 centimeters as my jump distance. Then you're going to take your calculator and you're going to calculate the average of your jumps. So you'll add all of your totals for your jumps. And you'll take that number and you'll divide it by 5 because you should have jumped 5 times. Now, there are some students that chose not to jump and just use my data as 100 centimeters. And I will tell you that those students only got half credit for this section of the assignment because just doing the 5 jumps is 10 points. And then using that data is 18 points. So if you do not record your jumps and you just use my data of 100 centimeters, you'll only get half credit on this section. So whatever you get for your average, whatever you have here in this box that I've highlighted blue, you're going to put that number all the way down this column. So you're going to take your jump distance and you're going to calculate the length of your jump on the moon and the other planets using this equation. So you're going to take the length of your jump on Earth divided by the gravity of that celestial body, and that's going to be your length of the jump either on the moon or that planet. I'm going to get my calculator. I'm going to take 100 divided by 0.17. And that gives me a very long answer. And I'm going to round that answer to the nearest whole number. Which is 588 centimeters. Then I'm going to take my jump distance and divide that by 0.38. And then round my answer to the nearest whole number. So you're going to take your jump distance divided by the gravity and record that in this column right here. Now, I've only calculated the inner planets. You will need to calculate your jump distance on each of the outer planets as well to get full credit. Once you've calculated your jump distance on the moon and all 8 planets, then you'll come down here and note your pattern. What pattern do you observe in the data table above? A planet with a larger mass has a stronger gravitational force. And so the stronger gravitational force, my jump length is here of the inner planets, which I calculated. Earth has the strongest gravitational force, and that was my shortest jump length. Because the stronger the gravity is, the more it's holding you back and preventing you from jumping as far. So again, we're going to graph our data in our Nearpod. We are only going to graph the inner planets. You still need to calculate your data for all of the planets, but for the Nearpod, we are only graphing the inner planets. So again, this column is going to be our X, and this column is going to be our Y. So for the moon, 0.0123, 588 centimeters. Very close to the 0 line. 588 is going to be just under the 600. Dot. Make sure my text matches my dot. Mercury 263. Mercury was 0.05. It's going to be in between the 0 and the 0.1. Whoops, undo that last thing. That puts my dot right there. Label it as Mercury. Venus, 0.8 and 116. Earth, oops, move Venus. Now your numbers will be different because your jump distance was different than mine. So whatever your numbers are for your jump distance, that's what you're going to grab. Whatever your numbers are on your table, you should see the same trend. The higher the gravity, the shorter the jump distance. The lower the gravity, the farther you're able to jump because there's less gravity holding you back. When you're done, be sure that you hit submit. This last section, section 5, we ask that you all do independently. So please make sure that you answer these 3 questions before submitting your assignment. Let's look at this question. What relationship between the mass of a planet and the student's weight on the planet, how does that relate to its gravity? So if I go back to my Nearpod, then we can see that as the mass of the planet increased, then the gravity increased, then so did my weight. So more mass on the planet, higher gravity, higher weight for me. And the next question has to go with the next table. And it talks about as the mass and the gravity of the planet increase, how does that impact your jump distance? So answer questions 1, 2, and 3 on your own. Before you submit, make sure that your answers are showing up in your Canvas window. If you have any questions, you can always email me.